Hi, welcome back. In this lesson, we'll be introducing you to OOP. What is object-oriented programming? OOP is a programming paradigm based on the concept of objects which contain data, often known as attributes or property, and procedures or functions which we call them methods. The four OOP concepts are 1. Classes, objects, and instance. 2. Encapsulation. This is where we hide the data. 3 is under inheritance. 4. Polymorphism. Now, first let's talk about class, object, and instance. What is a class? A class is a template or a blueprint to create the objects. For example, the class vehicle has attributes or properties like number of wheels, number of seats, number of doors, the engine capacity, the vehicle numbers, the owner's name, and color. These are all the attributes or properties of a vehicle. Now, besides the attributes and properties, it also has method to work on all these data. Methods like get the vehicle number, sets the owner when the vehicle changes to a new owner, or to check whether it's the fuel empty methods, and then also the method to top up the fuel, or method to move, or method to scrap the vehicle. So we use this Unified Modeling Language UML class diagram. Now in this class diagram, we will have to indicate the class name and then the attributes and the methods. Now the negative sign there shows us that the attributes are all private, and then the plus sign shows that all these methods are publicly available. So this is a UML class diagram of a vehicle class. So the attributes are number of wheels, number of seats, number of doors, engine capacity, vehicle numbers, owner's name, and color. All these attributes are private. Now then the methods available, it allows you to get the vehicle number, it allows you to set the owner's name, and then it allows you to check whether the fuel tank is empty or not, and to top up a certain amount, or to move to a location or scrap the vehicle. You can use online tools like draw.io to help you draw the UML diagram. Next, what is an object? An object is an instance of a class. We have just mentioned about the vehicle class. So what is an object of an instance of the class vehicle? Now the following are the three objects of the class vehicle: a car, a motorcycle, or a bicycle. The class vehicle provides a blueprint so that when you describe a car, a motorcycle, or a bicycle, you describe by naming the attributes on number of wheels, number of seats, number of doors, the engine capacity, the vehicle number, owner's name, and the color. All these objects have the same blueprint as detected by the class vehicle. Now look at the first object, car. Car has four wheels. The number of seats, the number of door, the engine capacity, vehicle number, and the owner's name and color has been left empty so that when we create the instances for the car, we can fill them in. Another object called motorcycle, it has two wheels and the rest of the attribute has been left empty so that when we create the instances for the motorcycle, we can fill them in later. In the case of a bicycle object, it has two wheels, one seat, no engine capacity, no vehicle number. So these are three objects of the class vehicle. Now let's talk about instance. What is an instance? An instance is a specific representation or occurrence of an object. We named three objects just now: car, motorcycle, and bicycle. Let's take the example of the object car. We can have different instances of the object car. So the following are three instances of the object car. It can be John's car, Peter's car, City's car. They all have four wheels, but some have four seats and some have two seats and some have six seats. The number of doors may be different. Peter's car has two doors. The engine capacity can be different. John's car is a 1500cc. Peter's car is 3000cc and City's car is 2000cc. And the color can be different. The vehicle numbers are different. Owner's name are different. So these are three instances of the object car. Before I move on to encapsulation, I want to talk about abstraction. What is abstraction? Abstraction hides the complexity or the details of the implementation from the user. So in the case of OOP, the user only need to know what are the methods publicly available to operate on or operate with the data. The user need not know how a method is implemented. They just need to know what it can do. Now let's talk about encapsulation. The word encapsulate means to enclose something. In the case of OOP, we encapsulate the data and the method which operates on that data. We put the methods and the data together into a single unit and we call it an object. So it looks like a capsule. So within this capsule itself, we have the data portion and the methods portion. By doing so, we hide the private data and make available only some methods to operate on or with the data, so that the user cannot have direct access to the data. So what are the benefits of OOP? Well, we mentioned about abstractions. The user just need to know how to use, need not know or understand the detail of the implementations. The data is being hidden. The user can only use what is available publicly, the methods, to access those data. In our next lesson, we will be talking more about inheritance and polymorphism. We will now consider the class person, and this is the UML diagram of a person. A person has an ID, has a name, handphone, date of birth, and email. All these are private attributes. Then for the methods, we have a constructor, and then some getters and some setters. The setters are the modifier, the getters are the accessor. And then we have a utility methods which help us to display all the information. Now when you write your code in Python for the class person, it will look something like this. First you name it the class person, and then you have the constructor and some getters and setter, and then you have a utility method. I'll go into each part in detail. Now, what is a constructor? Constructor is a method. Okay, it's a method that creates an object and it allocates the memory storage for the data. So it's defined by class person, define underscore underscore, init underscore underscore. Now within the bracket here, you see 6 parameters. The first one, self, followed by 5 more arguments for the person class. So there are altogether 5 arguments, excluding the self. The next 5 lines, we assign the self.pid to the ID, self.name to the name, self.hp, which is the handphone, self.date of birth, self.email to each of these arguments. Now, some people choose to write class person bracket with an object. It is not necessary, but you may come across certain literature or online material that uses that. When you write the code for the constructor, there are 2 underscores before and after the init. You must always remember when dealing with OOP coding, the self is the first parameter in every method. Next, we will talk about the accessor. These are commonly known as the getters. Now, accessors are public methods provided to access the data. So when you want to get the ID, so it will return self.pid. You'll get the name, it will return self.name, and so on and so forth. You can get the handphone number, date of birth, and the emails. Next, we have the modifier, commonly known as setters. Modifiers are public methods provided to modify the data. The first modifier we have is the set email. So in order to change the email, you must provide an argument of the new email. Then next, you just set the existing email to use the new email. So that's how you modify the email address. You can have also another modifier called set handphone, but you must provide a new handphone number, change the handphone number. Please note that there is no output from the modifiers. Utilities. Now, display is an utility methods. Now, when we display all the informations from the object, like the ID, the name, handphone, and date of birth and email, always remember to provide some meaningful label so that we know what are these data or what are these values for. Now that we have written the code for the class, we must know how to instantiate. To instantiate is to create an instance of an object. We can assign P1 to a person's object with an ID of 1, the name Lim Ah Seng, and a handphone number 1234567 and the date of birth and his email address. And to create another instance P2 of this Tan Ah Lian with a handphone number, date of birth, and email address. Now, when we try to print these two objects, the output will point to you a memory space. So these two objects will occupy two different memory address. How do we apply the methods on the object? P1 is an instance of the person object. We can use the method called getName, and this will provide you the outputs of the name for P1, Lim Ah Seng. You can also use the method setEmail on the object P1. And when you set the email, you must provide a new email address. The previous email address is limaseng@hotmail. So now you change the email address to johnny@hotmail. There is no output for the modifier methods. And when you use the display method on the P1 object, it will output all the informations of Lim Ah Seng. Now that you have learned what is a class, what is an object, and how to create an instance of the object, you may proceed with the question in cosmology and try out for yourself.